There's nothing like completing survey data collection. It's so very excited. You want to get in and dig into that data. You won't want to wait. However, you will have to practice patience, for there is work to be done. And in this presentation, that's what we'll be talking about. We have shared some resources on data cleaning, data analysis, and data presentation. There's both videos and readings. And this presentation highlights a few data processing procedures and shares additional examples on data coding and cleaning. So clearly there's a transformation of the survey data from what the respondents share and then what we eventually analyze for the results. The first part of the transformation involves coding the data so it can be numerically analyzed. So specifically, you'll take every questionnaire and assign it an ID number, and then take every question and name it for entry into Excel, SPSS, or R, whatever similar data processing software you're using, and then code the responses for the analysis. Let's take a look at what that looks like. So here's an example of a few questions that were coded. You see on the main activity question, the question asked the respondent to choose one of the activities listed, indicated by those tick boxes. And then there's also a question about how far did the person travel from their home to this particular site. When we look at the coding example of that, you see that the coding question now has a name, main activity, and each of the activities has been assigned a numeric variable. So if a person selected one, for example, they'd be coded as hiking. In the second example, you see that distance traveled is an open-ended question, and the person will just input however far they traveled. So let's take a look at what that looks like in the software itself. To do this, you enter the variable names and codes into the data processing software. And in this case, you see the columns for the variable name, the type of variable, numeric or alpha, as well as the value labels there. When you're actually doing this in the software, this is what the screen looks like. When you assign a value for the variable, in this case main activity, you type in the value and then the label. So you already see that the labels have been assigned for the activities we have, 1 equals hiking, etc. And this is what it looks like when the data is actually all entered. You see the identification number, the main activity number, and then also the distance traveled data. And you see a few things there that were not numerically numbered. The mushroom picking, for example, so that wasn't one of our choices, so that's an alpha variable. When we run the descriptives, you'll see the frequency analysis here. And in this case, we see that the most frequently engaged in activity was camping, which is indicated by that 43%, followed by hiking, indicated by the 22%. Yes, I'm rounding up a little bit. Note, we always use the valid percent as it excludes missing data. So what if you run those frequencies and you see something that doesn't belong? That's when we get into the data cleaning and transformation. As Nickerson and colleagues suggest, you need to detect the data issues and then correct them. Although some call this time-consuming and tedious, it's very important to ensure data quality. So data issues can be detected primarily through running descriptives and frequencies and noting implausible values, missing data, or diagnostics that indicate the data is skewed or too strongly correlated. Here's an example of an implausible value. This is the question that asks respondents to choose one response in terms of how many times have they visited the area before. And here are the descriptives we ran on that variable. Do you see anything amiss? When the descriptives were run, a 9 came up. 9 is not among the possible responses. So what do? It's time to correct the data. The first thing to do is to go back into the data and find the respondent's information. Find where that 9 is, and if it was a different response, you can correct the data. If there isn't a clear response, we don't know what the respondent actually input, we can look for context clues and the variables around that and see if there's something that can help us decide how many times the person has been. For example, there might be another question that's related to it that would inform it. If possible, you do want to correct the data so you can retain that variable and the case for further analysis. However, if you're unsure, the most conservative and safest bet is to code that as a missing entry. I do want to note that anytime you change the data, save the new corrected file with a different name. Always retain the original data and then continually save as you change the data set. This will save you any hassles if something goes amiss and you need to go back to a data set. I tend to consistently rename my files with the date I've worked on it and then clean data. Another data issue relates to missing data. Missing data can show up in your frequency runs. You see it there typically at the bottom of the descriptive analysis. And first you need to understand, why is this data missing? Is it a design flaw in the questionnaire? Was the question sequenced such that people were just missing it and literally just didn't see the question? Is it some sort of sensitive information that people don't want to share and that's why they're not responding to it? Sometimes age or income people don't want to answer. If there is a pattern of missing data, you need to be aware of. And sometimes you will have skip sequences, and that would be plausible and okay missing data. If you have a question, have you visited before? No, then skip to this question. That's an okay skip pattern, but there may be others that are not. Whatever the reasons, you do need to address the missing data. Approaches to missing data will vary depending on how much data is missing and why the data is missing. Some options to address the missing data include using the average of a variable to replace the missing data, doing a regression model to predict what that response would have been. It really just does all depend on how much and why the data is missing, so you'll have to adjust and address this as a case-by-case basis. One important note is that if enough data is missing, you may not be able to use the questionnaire or the variable you're interested in. Usually 60% is a rule of thumb. So if someone completed less than 60% of the questionnaire, you can't use that. Or if 60% or more of a particular data point is missing, you shouldn't use that. Whatever you decide to do with the missing data or other data issues, you need to document your changes. Any changes you make to the data need to be consistently, comprehensively, and accurately noted in a data diary. This enables people to replicate the data analysis that you did and understand what you did years later or days later, whenever it might be. The data diary really serves as a roadmap and documentation as to how the raw data got clean and any data transformations that were performed. For example, here's an entry in a data diary where the person noted a recoding of the variables. The question related to how many times a person had visited the site in this year. And what was done is you can read that they recoded all 0 responses to 1 for that particular question with those 3 ID numbers. And obviously, if a person is at a site, they've visited at least 1 time, so that 0 would be an inaccurate data point. Here's another example of a data diary entry related to data transformation. In this instance, the person took the question, what year were you born, and created an age variable. So we could run the analysis on how old they were. And then they also recoded that data into categories for analysis as well. So once you've assessed and corrected any data errors, run your frequencies and descriptives on the clean data, and it all looks good, then there's nothing like moving on to the analysis. You'll get a chance to practice data analysis and documentation in the research practicum for this week. The videos and documentation will be of great help, so I suggest you use them. Enjoy! I look forward to seeing what you find.